Okay, so as per usual, going to go through the kind of schedule for this week, what to expect, a little bit of housekeeping, and then we'll get straight into this week's content. So let me share my screen. Head over to our new folder here. So we're now on week 8. Time sure flies fast. Week 8, the new folder's up. Pretty bare bones week. We're continuing kind of on with assignment 4. We're getting some new commands that we're going to get through today. Otherwise, not anything hugely new. No new assignment just yet. Nothing crazy for this week. Okay, so week 8 folder, just the task list in here. If I pull up the task list itself in here, standard resources as per usual. 3 tasks for this week. They're not huge tasks though. Task 1, we're going to finish up chapter 11. We've kind of talked about break and break at point last week when we talked about trim and extend. It was kind of within that subchapter, so I covered it then. So we'll kind of do a little bit of a review, just kind of give you an idea again how those work. Not going to go into huge depth with them because we've already covered them. We'll talk about fillet and chamfer, 2 new commands, slightly more advanced commands for editing. Array, we've also kind of talked about in the past, especially with assignment 3. We've used rectangular arrays already. We kind of know how those work to some extent. We're going to cover also polar arrays and path arrays today. Okay, so big 2 are kind of fillet, chamfer. We're going to go into some other types of arrays. Those are the kind of main new things for this week. Okay, and then with that chapter is the associated practice problems. Practice 11C, 11E, 11F, H, and I. All of those are associated with these commands here. Okay, so they're kind of a bit more practice, a bit more experience with break, break at point, fillet, chamfer, and array. Okay, so that's what we're going to be talking about for this week. That's all that's kind of new, really. Task 2 is to continue on and complete assignment 4. So there's going to be a lot more time this week during class time. Assignment 4 has quite a lot of instructions behind it and a lot of kind of little details. So we're going to give you a bit of extra time this week as well to kind of catch up with assignment 4, just in case you need to ask questions during class time. That'll be available to you this week as well. Okay. Finally, task 3 is extra practice 5. Extra practice 5 will mainly be covering these advanced editing commands from chapter 11. It gives you just a bit more practice again with those commands if you feel like you want to kind of challenge yourself, or if you just want to check that you're kind of up to speed with all of those commands, then by all means you can complete extra practice 5 as well. You don't have to hand it in. It's an extra practice assignment, so you don't have to hand it in or anything. It's not for marks. It's just for you to kind of try out and, again, confirm your skills or challenge yourself or just get some extra practice. Okay? So that's the main task for this week. Again, a bit of a light-loaded week this week. Next week, things are going to pick up a little bit again. Just to kind of give you a bit of a preview into next week. Next week, we're going to be talking about blocks, which is going to be a fairly significant topic, let's say. So we'll talk about creating blocks, how to use blocks, how to edit blocks. That's going to come next week. It's going to be a very fairly advanced kind of topic, fairly bulky topic. And assignment 5 will come out next week as well. Okay. That's pretty much it in terms of schedule. Other thing I have to mention, I didn't do any grading just yet with assignment 4 this last week. I'm going to give you a bit more time with it first before I kind of go and grade a bunch of them, just for helping me kind of standardize how I grade your assignments. It's a bit easier if I get more of them at once to make sure the grades are kind of evenly spread, just so my grading doesn't change from day to day too much. So I'm going to give you a bit of extra time before I start grading those. So just a heads up, there's going to be a bit of a delay for that as well. Okay. Any questions about what to expect or any of the assignments or anything like that? All good? Okay, let's get into it then. So, first, let me start a new drawing here. We're going to do just a little bit of a re-review. Just again, since this week kind of mentions break and break at point, we'll talk about it just a little bit again, just a bit of a re-review, but I'm not going to go into huge depth. So again, break and break at point are two kind of methods that we can separate objects, especially lines, into into two separate objects. Okay. So if I have some line segment, I can use break at point to separate that line into two separate lines. If I use break, break will create a gap between those two lines as well as separating them into separate lines. So if I make a line segment, just a horizontal line here, this is one object. If I go to my modify panel and in this extended menu beneath, just by clicking the word modify or anywhere in this bottom bar here, I get my extended list. And down here we have break and break at point. And again, these are just to break lines into multiple line segments from one object to two objects. So I can take break at point, I can select anywhere along this line, or I can use any of my object snaps. I'll use the midpoint as this example. And by selecting that midpoint, I've now separated this line into two separate objects. Okay. And this has a wide kind of array of different applications. It might be the case that I have some line segment and I'm trying to get an object snap along this line, but none of my object snaps really work for that purpose. I can't use maybe midpoint if this is like as an example here, let's say this is a 7-unit long line and I want to have kind of reliable object snaps, but only 2 units along this line from the start moving to the right. I want a snap to use 2 units away. Then I might use something like break to allow me to have that accessible object snap for kind of later purposes, maybe. If I use break, I can select the object, maybe use my object snap tracking, enter 2 units away from that object snap, hit enter, and now I have a reliable object snap, an endpoint snap that could be used to now kind of branch away from that object snap there, that break. Okay, so I can draw off of it. This would be the case where I'd use that endpoint pretty often. If I was only doing it once, I could just get away with object snap tracking once. But if I'm kind of recurringly using this object snap, maybe it's a good idea to break there. You could alternatively use a node. That's also a different way that you could do it. In some cases as well, the other kind of big overarching application is if I have some sort of drawing and it comes in maybe circles and rectangles, something like a polyline. So I have something like a rectangle. This being a polyline, it's only one object. Maybe I want to separate this in some way to kind of divide it up. I could use break at point, maybe set it at the midpoint, set it at the other midpoint here, and kind of break it up so I could remove half of this object. Because if I were to use trim, trim looks for intersections, or if I go before I made those breaks, trim wouldn't work here very well to remove just half of this object. Erase wouldn't help me very much either because it's on an object basis. So maybe I want to break up that object into smaller pieces so I can more easily edit them. That could be another application. So they do come in handy. It's kind of niche, but they do come up quite a bit. Alternatively, with break, if I have a line segment and use break from my modify panel instead, this is going to create a gap while also separating my line into two separate, or my object into two separate objects. So now I've created two line segments and there's a gap between them. And again, big application for this one is often in wiring diagrams or process flow diagrams, things like that. You might have multiple lines that kind of overlap. So maybe this wire goes this way, this wire goes this way, and they're just kind of connecting off to some sort of element up here. Or let me redesign this. Let's say I know. Let's do this. Okay. So here's kind of my example here. How much depth do I have here? 1.5. So let's call this A to A. And B to B. Okay, so pretty basic diagram. I have some sort of element A, and it's going to this other element A, and an element B going to another element B. So the B attaches to the B, the A attaches to the A, but they do not interact. The A elements, their wiring does not interact with the B elements wiring. So in some cases, a big application for something like break at point would be, or break rather, would be to kind of separate this out. And then this kind of gives a bit more visual clarity to let the reader know, or other people that might be using your drawing, that this A is not connected to the B wiring. It's not a four-way intersection. It's two separate linear lines. So that might be kind of a reason why you'd use that. That's generally a really big common reason that you'd use it. But of course you could use it to make any gap between a line segment. Maybe if you're making a doorway within a wall or something like that. There's a plenty of reasons where you might use it. This is very common with diagrams though. Okay. So that's a bit of an example into break and break at point. We'll move on though into some new stuff here. Okay. So starting out with fillets. So we're going to talk about fillets and chamfers. We'll start with fillets first. Fillets, as kind of a definition, first we need to know what a fillet is. A fillet is a rounded edge on where a corner would have been. Okay, so if I start with this rectangle on the left, this is my original rectangle. If I were to fillet the corners, I'm making these rounded corners on this rectangle on the right. So left would be my original rectangle here. The one on the right is post fillet. Those corners have been filleted, they've been rounded. Okay, so with the fillet tool, we're going to convert from this left one to this right one. So in order to do that, first we need to call the fillet command. Fillet being a editing command, it's editing an existing or modifying a existing object, this rectangle that already exists here. It is located in our modify panel. Okay. Fillet is this guy right here, this kind of rounded corner with the blue line segment, blue arc there. This is fillet just beneath trim. And with fillet, just like other modify commands, it's going to first ask us to select some objects. In the case of fillet, the objects that it's going to want are the two lines between the actual curve. So if I choose this vertical line here, or this horizontal line, sorry, at the top of the rectangle, and then this vertical line on the right side of the rectangle, it will make my fillet in that top right corner. Okay, so it's asking for the first object. That would be either of these two lines. The second object that's going to ask me for next is going to be the other line of that corner where those two lines intersect. Okay, so it'll ask me for my first object. I could choose something like the top of this rectangle. It's then going to immediately ask me to select the second object. It doesn't require me to press enter first because there's only two lines to define to make the fillet between. So it's going to immediately ask me for the second object. I can choose the line on the right side, and I can see I've already left something in here. Okay, so the next object I check or select is the next line. And if you haven't messed around with any of the settings, nothing happens. Okay, so the reason nothing happens is that AutoCAD is also going to need some extra parameters to define how big that fillet is. It doesn't know if we want this rounded just a little bit or if we want it rounded extremely, so this looks like an oval. It doesn't know how much to fill it off, okay? How much of this corner to round off, in other words. So we actually are kind of required to use some extra settings here. If I go back to my fillet command again, start fillet, if I press my down arrow on my keyboard for my extra options here, there's a option here for radius. So if I scroll down to radius, or I can use my mouse and just select it, then AutoCAD will ask to specify the fillet radius. And that radius specifically is the radius of this arc here. So this one I have on the right example. This arc, if I kind of imagine it as a larger circle, something like this, that arc and therefore that circle should have some sort of radius to it. That is the radius that I'm going to specify to AutoCAD to determine how big that rounding is of that corner, how much should be rounded off. Okay, so this radius here is this distance from the center to the arc itself. Okay, so if I choose fillet again, go down to radius, I've made my rectangle here. This example rectangle is 3 by 5. You can use the same one if you're trying it out as well. It doesn't really matter too much. Something you have to keep in mind is the radius should be acceptable to the size of the rectangle or the size of that corner. We'll kind of demonstrate what I mean by that as well. If I choose fillet, I know this is 3 by 5. I could set my radius to something like 1 and hit enter. Now I've set that fillet radius to 1. I can now go select the first object, select the second object. Before I go and click, it shows me a preview of what that fillet should look like. And then when I go ahead and click, then that fillet is formed. So if knowing that this rectangle is 5 by 3 in size, 5 units by 3 units, I can kind of safely assume a radius of 1 will fit. If I set this radius to something that's far too large, where AutoCAD can't make a fillet that large, it would take up too much of the line length and it would extend far down, wouldn't be able to do that. It's just going to say it's not acceptable. So if I make this fillet radius something very large, so like 20 units in radius, I'll select the first object. When I go to select the second object, it says the fillet radius is just too large. Okay. So you do have to kind of have a little bit of an awareness, either existing on the blueprint already kind of in the specs, it might already tell you what that radius is, or if you're kind of just making a drawing that's not very particular to the dimensions, you might be kind of guessing what that fillet radius might be. Just keep in mind the fillet has to be small enough that it fits within the lines that it's being formed from. Okay, so to kind of re-summarize all that, using fillet will make me a rounded corner. I need to first specify what the radius is. If I don't specify a radius, it won't do anything. It'll just leave it as a 90-degree angle. So I do need to set the radius first, just from the down arrow menu. I'll set it to something like 1, knowing my rectangle is 5 by 3. A radius of 1 should fit within that. Select the first object, the first line of the corner that I'm going to fillet. Select the second line of that corner that I'm going to fillet. And then my fillet is formed and I get that rounded corner. Okay. Any questions so far about filleting or with breaking that we've kind of talked about already? Okay. So that will make me my rounded edges, or rounded corners. With fillet as well, we have some extra options that we can use in our down arrow menu. With fillet itself, if I press my down arrow, I get not only radius, just to specify the radius of that fillet, but we also have a few other options here, specifically undo, polyline, trim, and multiple. Okay. These are largely to help us speed up the process. In terms of, if I reset my rectangle here back to its 90-degree corners, if I go and fillet and choose something like polyline out of this list, this will fillet every corner on a polyline. So if I choose polyline, knowing that my rectangle is made with the rectangle tool, that should be a polyline. If I select polyline out of this list, then, and make sure I set my radius as well, put it back to 1. And if I hover over my rectangle, I get the preview. And since I've set it to polyline, it's going to round every corner of that polyline. Okay. And this doesn't have to be a closed shape. It works for straight polylines, like kind of jagged lines. It doesn't have to be a closed shape. If I do polyline command here and make some kind of zigzag here, if I go and select this and fillet, go down to polyline, make sure my radius is set, and hover over that polyline, that zigzag, you can see the preview will try to fillet every single corner on that polyline. So it doesn't have to be a closed shape. You can see on this drawing, or on this zigzag that I've drawn here, it missed one of these corners here. So this one is still 90 degrees. Again, that's because the radius that I set is too large for that corner. There's not enough line length to fit that fillet in there, so it skipped it. Okay. So big thing to kind of be aware of, you do have to set the radius, otherwise it's not going to do anything. And that radius has to be small enough that it can actually form that fillet. Okay.
Will it recognize several line segments that are tied together as a polyline with polyline command on fillet? Or does it have to be a polyline item or element?
It has to be a polyline, but if you use line segments and then use join to connect them, it will still recognize that as well. So if I use separate lines and just make them, each one of these is its own object. If I go ahead and take these and then join them, then I can go ahead and use fillet with the polyline. And it'll do those. But it has to be one object, is the only kind of limitation. Okay?
Awesome, thank you.
Yeah, no problem. Okay. So that's kind of to quickly do rounded corners, especially when you have rectangles that are rounded. If you think about, like, I don't know, your phone or your phone case, if you're kind of developing something like that, it has the filleted or rounded corners. So if you're designing something like that, anything with rounded corners in general, that's kind of a quick way to do them all at once. Okay. Along with that as well, with my down arrow menu, we also have multiple. Multiple is going to do kind of similar thing where it's going to help us speed up the process. It just isn't going to do all the corners at once. If I choose multiple and make sure my radius is set, this will allow me to continue making fillets without it ejecting me from the command. So I can go ahead and make this top right corner. It'll keep me within the command, so I can do the next corner, and then the next corner, and so on and so forth. Okay. If I were to just not use multiple, so I'm just leaving it as is, then I'd choose two corners, and it ejects me out of the command. It cancels the command. So multiple allows me to stay within the command, and then I can do multiple at once without having to go in and type in fillet every time or choose it from the ribbon every time. It just kind of helps you speed up a little bit. But maybe in some cases you don't want to do all four corners. Maybe you just want to do three. So that would be kind of a case where you'd use multiple. Okay. So I do multiple, do three corners, and then just leave the last one as is. Okay. With multiple as well, we also have undo in this list. Undo is obviously kind of going to undo the most recent fillet if you're using the multiple command or the multiple tool here. So if I do multiple and I do multiple fillets here, let's do three, then undo is going to undo my most recent fillet in this sequence here. So undo, and it'll undo the most recent one, and so on and so forth. Okay. And then finally in this list, we have trim. Trim is going to determine whether that 90-degree angle is left intact or if it's going to be removed when the fillet is formed. So if I choose, right now, by default, it's set to trim. You can see if I go into the menu, trim has a little bullet beside it. So with trim, it's going to remove that 90-degree angle and replace it with just the rounded corner. If I go to no trim in this list, then when I make that fillet, it's going to leave the 90-degree intact. Okay. And of course, this can be useful in some applications as well. Maybe you do want to leave the corner in, maybe it's a component of something else and you're just making a arc that kind of fits that corner. Maybe this is like a gasket that's going to fit in here or something. Could be a wide kind of range of ideas here. So it can be useful as well. So that's just going to determine whether that 90-degree corner is left intact or if it's removed. Okay. Couple other tricks with fillet as well. That's pretty much it for the command itself. There's a couple other tricks you can do with fillet just for your convenience. What fillet can also do is that if I have two parallel lines, and I'm just going to make two parallel lines here, make them the same size. If I use fillet and I use two lines as my two fillets and they're parallel, fillet will form a kind of U shape or like a parabola to fill in the gap between those two lines. So it's not just for corners, it can also do these kind of U shapes, U-shaped ends. Okay. So just any two parallel lines, all I do is select fillet, choose the first object, choose the second object, and I'll make that fillet for that full rounded edge. You don't have to specify the radius in this case, because the radius is whatever half the distance is between the two lines. So AutoCAD's going to automatically calculate what that distance might be. So you don't have to enter a radius in this case. Okay, I just select the two lines and it'll form that fillet end for me. It's already kind of assumed what that radius will be just based on the distance of those lines. Okay, so that's another little trick you can do with it. The other trick is that if you do have rounded edges, something like this example here, and you want to revert this back to being 90-degree angles, you can just use fillet, set your radius to 0. And if I set my radius to 0 here, oops, let me polyline here maybe. Maybe it's not cooperating too much here. If you set the radius to 0, it should return it back to a 90-degree angle. I think I have an extra setting in here somewhere that's preventing me. But if you use fillet, set the radius back to 0. Oh, I know. It's causing me problems. Yes, my no trim was still on. Okay, so if I set it back to trim, fillet, down to trim, I just set it back to where it was. It was on no trim, I set it back to trim. If I do the radius set to 0, maybe polyline, I can revert this back to 90-degree angles. Okay, and if I go use my measure tool, I see the little orange squares in the corners showing me that that's a right angle, so I know it's been reverted back to a 90-degree angle. Okay, so it's handy in that case as well. You can use it to revert rounded corners back to square corners just by setting the radius to 0. Okay, so that's a couple extra tricks you can do with fillet. Any questions about that before we move on to chamfering? Okay, let's move right along then. So that's my fillets. Now chamfering is very similar. It's going to be editing the corners or kind of those intersection points of my line segments. But in this case, it's going to make a bevel or kind of an angled corner. So where fillet was making rounded corners, chamfer is kind of just cutting them off and giving me an angled corner instead. Okay, so this one on the left here is my rectangle I started with, and the one on the right is post chamfer. The corners have been chamfered on this one. Okay, so chamfer is a little bit more complex than fillet is. Fillet is defined just by the radius alone. We can select two lines. It'll make its calculations and throw that rounded corner in the rounded corner in based on that radius definition. Chamfering is going to use slightly different dimensions that AutoCAD is going to require in order to make this kind of angled corner instead. Okay, so starting out, the chamfer tool is hidden underneath the fillet command. So what I mean by that is that it's in this little drop menu where fillet was, the little arrow beside it, we get chamfer from the drop-down list. And you can see there's a little preview there that's going to turn my square corners into angled corners. And with chamfer, there's going to be a little bit of a different method to define the chamfer. What we kind of have to know is there's two main methods. We can either use two distances to define the chamfer or a distance and an angle. The reason being for that is that if you kind of imagine this was still intact, our chamfer kind of looks like a triangle here that's being cut off. So the two ways we can define that angle or that triangle that's being cut out there is either with two distances or a distance angle. And by two distances, I mean this distance here and this distance here. So if you kind of think about it as the adjacent and opposite sides of that right angle triangle, and the hypotenuse is the one that AutoCAD's going to draw for us. It's going to assume that based on our two distances here. So you can kind of assume AutoCAD's running Pythagorean theorem back in the background there, a squared plus b squared equals c squared, to figure out what this length is here. Okay, so that's one way we can define this. The other way we can define this is by a length and an angle. So if I do the other corner here, we can also define this triangle by a length and an angle. I guess it's not showing too well. That's fine. Let's move this a little bit. Need my font to be smaller. Let's just move it out. Okay, so I can also define this by a length and an angle. So what AutoCAD's doing in the background there is it's doing trigonometry. It's doing its sine, cosine, tangent in this case. So it's doing its little SOHCAHTOA in the background to figure out what this hypotenuse is, right? We have an adjacent to the angle. We have the angle itself. So we can kind of come up with what trigonometric form should be used to find out the hypotenuse. Okay, so it's a little bit of triangle geometry going on here. We don't really have to know what that geometry is because AutoCAD's running the calculations for us. But just keep in mind the two ways we can define this chamfer is based on two distances or a distance and an angle. Okay, so I'll leave those for now where they are. Again, if you're following along, this rectangle is just 3 units by 5 units. Doesn't have to be exactly that, but I'm just using that so I can kind of keep in my mind what numbers I should be using. So with chamfer, again, just up in our modify panel, we'll select chamfer out of the list. And chamfer, very similarly to fillet, will ask me for a first line and a second line, and then it's going to form the chamfer between them. Okay. So again, I'll choose the top left as my first, the the top as my first line, the right side as my second line, and it should form my chamfer as an angled line between those two. So if I choose the top one as my first, second one, and I've already set this again, second one as my second, the right here. Again, nothing should happen by default because I haven't defined my distances or a distance angle. So I have to go into my chamfer again. And again, I am required to go into my down arrow menu to define either two distances or a distance and an angle. The ways I can do that is from this menu, we have an option called distance. Distance is going to allow me to define that chamfer by the two distances here, the left example here. Angle from this list is going to allow me to define that chamfer by one distance and an associated angle. Okay? So these are my two options from this list, either two distances or distance angle. If I choose distance for my first example here, it's going to ask me to first specify the chamfer distance, specifically the first chamfer distance. Since we have two distances, AutoCAD also has to know which one is which. Which one are we starting with? Which one are we finishing with? So if I set my first chamfer distance to something like 0.5, and my second chamfer distance to something like 0.25, so two different distances, I'm not going to get a right angle or a kind of what's the word for it? Isosceles triangle in the corner there. I'm going to get something that has 3 different side lengths, okay? So if I set this chamfer now, I've set the first chamfer distance as 0.5, the second chamfer distance as 0.25. The first value that I input, the first distance, is associated to the first line that I'm going to pick. The second value that I inputted, the second distance, is going to be associated with the second line that I pick. Okay? So if I choose the left side here, that was the 0.5, and the top as the second line, which was the 0.25, then I get a corner that looks like this. And again, if I dimension this out, this was my first chamfer length or chamfer distance, 0.5, and this was my second chamfer distance, 0.25. Okay? So the first value that I input is associated with the first line that I pick. I pick the left line first. I input 0.5 first. So this left line is being chamfered by a distance of 0.5. Okay. I input 0.25 second as the second distance. I clicked on the top line as my second line. So that was chamfered 0.25. Okay. So it does matter which order you do them in. If I was using fillet, it doesn't matter which one I start with and which one I end with, because it's just defined by a radius. That radius isn't associated with either line independently, so it doesn't matter. In the case of chamfer, it's a little bit more complicated where the order that I pick the lines in and the order I put the values in do matter, okay? So if I do the same thing and set the distances, let me go back here. If I set the distances in the opposite order, again, going distance, my first one now will be 0.25. My second one will be 0.5. And again, I'm going to use the same order. I'll pick left, then top. If I go left, then top, now the left one has been chamfered 0.25 because that was my first input, the first line I selected. And the top has been chamfered 0.5 units because it was the second input, the second line that I selected. Okay, so again, put in the dimensions for proof here. 0.25, oops. And 0.5. Okay. So the order matters. It's a big thing to keep in mind. So that covers our distance method. The other method here is that I can use the angle method. So one distance and an associated angle. If I choose angle here, it's again going to ask me for the first line length, the first chamfer length. I'll enter something like 0.5. And now it's going to ask me for a chamfer angle. So that's specifically what angle is right beside that chamfer distance that I specified. That will make this line the adjacent line. If you're thinking kind of in trig terms, this would be the adjacent to this corner angle. We're using this angle is 45 degrees in the top left. This 0.5 would be the adjacent. This 0.5 on the right would be the opposite. And the resulting 45-degree angle line is the hypotenuse. So the first line is always the adjacent, and I'm putting the angle beside the adjacent. The opposite is going to be assumed. The opposite and the hypotenuse both are going to be assumed off of that data or calculated off of that data. Okay. So if I choose chamfer again, go down to angle, I'll set my distance as 0.5. I'll set my angle as, let's say, 30 degrees. Now, again, it's going to ask me for a first line and a second line. The chamfer distance that I input is associated with the first line. The second line is going to be automatically calculated based on the chamfer angle. Okay? So again, I'll choose the bottom line here as my first line, the right side as my second line. And now, since I input a distance of 0.5, this distance here should be 0.5. And I specified an angle here. And if I just put in a line, I can go ahead and measure that angle. And that is 30 degrees. Okay. So keeping this line, the distance that I defined is the adjacent. The opposite and the hypotenuse are being calculated for me. If I go and measure or put a dimension here for what this distance is, that is the calculated value for 0.5. And with a angle of 30 degrees, it's calculated the opposite for me. Okay. So it used its SOHCAHTOA rules there to come up with that value. Okay. So that's two different methods we can do chamfering. Generally speaking, the methods are only kind of come up usually based on specs that you're given. I'm going to use extra practice 5 as an example here. I'll pull up extra practice 5. It was one of our listed tasks here, so I think it's fairly applicable. Extra practice 5 looks like this. You can see on here, there's some of these chamfered corners on this shape here, this object, and there's some filleted corners in here all over the drawing. And you can see that it uses different methods for the chamfer in some different places. For example, the kind of overall largest shape here, the corners of that are 15 as the chamfer length and 45 degrees as the chamfer angle. These are typical for all the corners. The inner kind of octagon shape here in the center uses both a distance chamfer, 10 for the left side here, 20 for the top for that chamfer. Same with the top right corner here would be the same. And the bottom left and bottom right corners are using a chamfer length and a chamfer angle. So it's usually kind of spec based. Normally we'd kind of figure out what the dimensions of this kind of triangle shape or this corner cutout should be. And then we'd go from there based on what data or parameters or dimensions we already kind of know. We'd use one method or the other, but it's generally limited to when you choose one method or the other, it's limited to what information you have available. Just like most of our commands, we don't really want to make assumptions with kind of placing things or editing things. We don't want to make assumptions about how long this left side is of that triangle. So we generally play it safe, follow the dimensions on the blueprint. We're using whatever kind of parameters are available to us, whatever is known, right? Just same with like if you're doing math equations, you don't start with what's unknown or with physics questions or anything like that. You don't start with what's unknown. You first kind of read the question. You write down what you do know, like maybe the mass of the object if you're doing some sort of physics equation, or if you're doing Ohm's law, you know, resistance and voltage. You jot those down first, and then maybe you're looking for current. So you put I as your unknown value. But we want to generally be working with what we do know. I'm not going to make up a value for current that kind of fits my situation. I want to figure out what that voltage and resistance kind of equate to in terms of current, right? So again, we're working with whatever parameters we have kind of available to us. Okay. Similar to fillet, chamfer has its drop-down menu with kind of the same commands. Again, we have polyline. It'll do the whole rectangle all at once or the whole polyline shape. If I reset this here and set my chamfer, we'll just do a simple one, of chamfer distance of 0.5 and 0.5, just to make a 45-degree angle. If I set it to polyline, then it does the whole polyline shape at once. And it works just like fillet. It'll work on a zigzag shape as long as it can fit the chamfers. So if I do a zigzag, it's not a closed shape. I can do the same thing. Make sure these are set. Polyline. And I made this with line, didn't I? So I can chamfer an entire polyline at once. Okay. Doesn't have to be a closed shape. As long as it's one object, it's one polyline, it can do all the chamfers at once. Okay. Also, similarly, we have multiple. I can do multiple within the same command, so it doesn't kick me out every time. And I can undo each one individually. Same idea as fillet, same commands. Trim will leave the corners intact or remove them. I can set it to no trim, and it'll leave the 90-degree corners intact. The only different one in this list is method. Method will allow us to switch between distance, the two distances, or distance angle. The reason why that's in there is the data parameters that you store. If I input in distance 0.5 and 0.5, and if I switch to angle and put this as 0.25, 45 degrees, I can use method to kind of switch between them. I can use distance, go back to method, switch back to angle, and use the other method. It doesn't really matter that much. It just kind of is because AutoCAD holds the parameter data for distance, the distance method, and the angle method. It holds them separately. So you're able to kind of switch within the command between the two methods, and you'll be able to recall the same parameters over and over again. It's not highly useful, but it's just because the data for distance and the data for angle are held separately. Okay. And that just allows you to switch between the distance method or the angle method while keeping your parameters intact for them separately. Okay. What else here? Okay, I think that's about it for chamfering. Any questions at all? Okay. No fun tricks with this one, really. If you set your chamfer distances both to 0, it'll make your right angles again. But there's no fancy way of taking two parallel angles or two parallel lines and making a connection between them. Chamfer doesn't do that, only fillet does. Okay. So, moving right along then. Check my time here. Okay, it's about 6:54. We'll take a quick 10-minute break here and we'll reconvene at 7:04 and we'll continue on. We'll finish up with arrays and then the rest of the time is just kind of free period time, either working on practice problems or on assignment 4 or any other assignment really. Okay, so we'll come back at 7:04.
Hey Brent, I got a quick question about doing the conduit in our arena floor plan assignment.
Sure.
So I was currently the other night I was just doing it in the started doing it in the mechanical and the dressing rooms of the drawing, and I was trying to match it pretty similar to how you had designed it in the original documents there with the 45s coming from the lights and then the parallel lines in between.
Yeah.
And the way I was doing it was basically running two individual 45s on either side of the where the lights come from and then connecting the lines in between after. And it seemed pretty tedious and was kind of slow. Do you know if there's a faster way of doing it?
Yep. Let me make a mock-up here.
Hey Brent,
Yep.
um, quick question for you. For are we supposed to do something with the layers so that we don't have the grid showing up on layout 3 on
Yep.
assignment 4?
Yes. So in your layer control, once you've finished the luminaire layout grid, all you have to do is just turn off that layer, so it's not shown anymore. So if I go, I'll quickly share my screen for this one here. So you've already drawn your layout grid. So at kind of this point, you've made your layout grid, you've put the luminaires on top. Now you do need to do the conduit. Conduit and the luminaire layout grid are both yellow, which is kind of annoying. And the lines overlap as well a little bit, which is also annoying. So all I have to do is just go to my layer control here. I'll turn off luminaire layout grid, and that will just hide it for me. And then I can turn on conduit and then draw conduit as needed. Okay. So by turning it off, it makes it non-interactable, not visible, so you can just hide it. We don't want to delete the layout grid though, because it's still a component of the project. So you don't want to go around deleting the layout grid. You can just turn the layer off just to hide it. Okay.
If we added something completely in the wrong layer, how do we add it? How do we add it to the correct layer? Can we just like select it all and then paste it into that layer?
Yeah, you can just select whatever you want and then move it to the layer as needed.
Okay.
You could merge layers, but it would be pretty risky. You could take a layer and then try to merge it with another layer if it's like a huge amount of stuff that you've kind of included. You could merge it with another layer, just using merge selected layers 2 out of the layer properties here. Merge selected layers 2, and then choose the layer that you want to move all of that stuff to. The problem is it's going to delete that layer, so you're going to have to rebuild it. So make sure you keep note. If I have like the luminaire schedule here, or the layout grid, and I accidentally put the layout grid on schedule, just keep note of what the properties are of the schedule layer. And you could just take this merge selected layer to the layout grid. So I'm going to take everything from the luminaire schedule where I accidentally put it on, move it to the layout grid, hit OK, hit yes. That will remove my schedule layer and move everything to the layout grid layer. But now I have to rebuild that schedule layer. So keep note of what the properties are. Okay.
Okay.
Yeah. Okay, so going back to how to make this a little simpler for the conduit. Easiest, probably most elegant way to do it, I'd think, is first of all, going back here to the conduit. The conduit itself is basically a rectangle, but there's little segments here where there's this little triangle kind of shape or this little arrow shape that pokes out.
Yeah.
So I'd start by going to the drawing and taking my rectangle and then making sure this lines up exactly where it's supposed to connect. So the quadrants of the circles. I could use that snap, draw my rectangle, find the quadrant snap of this luminaire, form that rectangle there, and that's kind of the basis of my conduit there. All I have to do now is just trim out this side and make those little V shapes.
Okay.
I can just quite simply take this quadrant, use my polar tracking to make a couple 45-degree lines that pass through it, then trim out the excess, and there I have my first triangle shape or V shape.
Okay.
Then what I could do, if they're evenly spaced, I could really just take this and kind of copy and paste it over and over again. Or if I want to be extra kind of rigorous with it, I could just take the individual V shape, make sure I'm copying it where it's kind of precisely being placed, and just kind of plop it along every one of these circles.
Oh, that's slick.
Yeah, you could try using chamfer. Chamfer could be applicable here. I think it would be a bit too much effort though, so this is probably a little bit easier.
Yeah, just looking to streamline, not get fancy.
Yeah. And then you can just trim out all the extra lines.
Gotcha.
Yep.
Okay, awesome. That helps. Thanks.
Yeah, no problem. Okay, it is 7:04 now, so we'll keep chugging along here. Moving on with our last topic for today, arrays. We've already kind of talked about rectangular arrays, so I'll do a little bit of a re-review on that, but not too much detail. So with arrays, arrays in general are going to generate kind of copies of whatever objects we select into a bunch of objects at set intervals or set distances between them. So if I do something like a square here, oops, I'm really zoomed out. Bring my units back to planet Earth here. Let's do 50 by 50. And if I use my rectangular array, again, the array tool is now below the fillet or chamfer tool. To the right of the scale tool here is rectangular array. And by choosing that, it gives me a default array. I can set how many columns of shapes I have here, how many vertical columns, how many horizontal rows, the amount of distance between each column or row. So I can put them pretty close together. I can put them super far apart. Same with the rows. I can change the number of rows here down to 2, up to 5, change the distance between them up to something like 200 to make them bigger, down to 75 to make them smaller. We've kind of used this for assignment 3, so you're all pretty familiar. Big thing here is the associative button. Associative is going to determine whether that array remains as one object or as each object that I kind of started with, each square in this case, is going to be its own object. So if I check associative and then close my array, this is all one big object, one big array object. All of the squares move together. They're all one object. If I do the same thing and make it not associative, so not checking this box here or this, making sure this button's off, and close my array, then each square is its own object. That was kind of the big catch with arrays. Okay, so these are all individually editable. They're all their own object. You can change between them slightly. If I have a rectangular array and it's associative, then I can just use explode to break them back up into individual components. Explode is always going to take one object and break it into its most immediate parts. So this isn't going to break every square into line segments. It's still going to be a polyline rectangle because I use the rectangle tool. It's just going to take it from the array level down to the rectangle level. So explode, this is now down to the rectangle level. If I explode it again, now each one of those line segments in the rectangle is its own object. So it's taking it one step down in terms of separating the objects out. Okay. It's a little trickier if you're trying to make this back into an array. You kind of have to just get rid of everything else and then start again. Okay. So you can explode to break from an array down to an object, but there isn't really an easy way to get from one object to an array. So that's kind of a re-review into rectangles or rectangular array. We're going to talk about polar array today and path array. Okay, so those are two other array methods. Again, with our little drop menu here, we have rectangular, we have path, and we have polar. We're going to talk about polar first, even though it's the last in the list here. It's a bit simpler than path. Polar array, as it kind of shows in this little demonstration image here, is going to array objects out into a circular pattern. So a certain radial distance away from a center point. Okay. Rather than making rows and columns, we now have kind of rings expanding around a center point in circular shapes. Okay. So I'm going to quickly draw a triangle here just for kind of demonstration purposes. It's a bit easier to see a triangle when it gets rotated. Let's do something like this. Just have a nice right angle triangle here. I'm going to join it, but it doesn't really matter. Okay, so I'll take this triangle here, selecting polar array out of my little list here is going to give me a defaulted polar array. But first, unlike rectangular array where it just kind of throws it in a bunch of random columns and rows by default, we first have to define what is the center of this array. Where is the center point so we know how much radial distance, how much radius from the objects to the center point. Okay, so I'm just going to freehand click wherever. I'm going to click down to the right here. And wherever I click, I create a polar array, a ring of those triangle shapes. Okay, so by default here, it's made one ring of 6 triangles. And again, we get our array creation ribbon at the top, our new ribbon. We can change how many items are in the array. So right now it has 6 triangles. We can reduce this down to just 2. We can increase this to something like 20, and we get a whole bunch of triangles in that array. We can change the distance between each triangle. So if I change this to, say, 50, oh, oops. Do I have it set properly here? Right, I won't be able to. Okay, so I can set the amount of items, but it's going to try to fill the entire radius or the entire circumference of that circle, of that array that it's forming. If I change the fill here, the fill angle is the amount of the circle that it's going to fill. Right now it's set to 360 degrees. So these triangles are going to be placed the entire circumference of that array around the entire 30 degrees. If I change this to 180 degrees, angles are only on one side of that circle. Okay, so 180 degrees. The way it determines where these triangles are placed, it's using the object that I started with, the very first triangle, which was this one in the kind of top left here. That was my very first triangle. Let me reduce the amount of triangles here. So this was my first one, and it's creating more triangles counterclockwise. Okay. So the reason why it picked this kind of angle as halfway of the circle is because it's choosing the very first triangle I started with relative to the position of the center point and then expanding them out counterclockwise. Okay. I can change that rotation angle by using this rotate items or this direction button here. If I uncheck direction, it's going to spin it the other way. So now they're expanding out clockwise. Okay. So if I change the direction, it's counterclockwise, expanding those out. I can change this fill angle to 270 degrees. It'll fill 3/4 of the circumference. Changing the direction again, now they're going clockwise. Okay. Counterclockwise and clockwise. Okay. So we can change some of the parameters in that way. Oh, I shouldn't have exited out. There we go. We can also change the number of rows or rings of this array. Right now we have just one ring of triangles. Let's increase the number here so it's a bit clear. If I increase the number of rows to 2, now we have 2 rings of triangles going around that center point. So we have the inner ring of triangles and the outer ring of triangles. So we can make multiple rows or rings kind of expanding out from that center point as well. Okay. So similar to kind of rows, columns, we have items, how many are placed around the radius, and then rows, how many rings do we have of those objects. Okay. And we can change the distance between each ring. I can increase this to kind of spread them out a bit more, or decrease it to bring it back in. This internal radius, the reason the inner ring isn't moving in or out at all, is because that was defined when I made my first triangle and I set that center point. That radius from the center point to the first triangle is now defined. It's kind of a hard parameter. It's not going to be changed. Okay. So that doesn't expand or contract in any way because that was determined by when I set the center point of the array itself. I can change that center point using the base point button, and I can kind of change it a little bit. And now it kind of expands and contracts a little bit around to that new base point. And I can also, I think I lost the command here. Let me go back. Set the center point again. And lastly, or well, second lastly, we can set associative, first of all. Again, similar to the rectangular array where the objects are all or the triangles are all one object, or if they're their own independent objects. And finally, we have this rotate items button. And this is going to determine whether those items, the triangles in this case, are going to be rotated based on their placement around that array, or if they're going to match the orientation of the original triangle. So this one here in the top left was my original triangle. Right now they're rotating as they go around the array. So they get rotated a little bit. You can kind of imagine there's a tangent line here. If there's a center circle, this is tangential to that center circle. Same with here, tangential, tangential again, etc. If I uncheck rotate items, then they all match the orientation of the original triangle. So this was my original, it's upright, now they're all upright. If I switch it to rotate, then they rotate based on kind of how they are placed around that array. Okay, so I kind of demonstrate here. I can kind of draw tangent lines here. I'm just going to eyeball them because I don't want to find out the exact angles. If I take the base of every triangle and kind of make a tangent line here, they're all they're all tangential to kind of this internal circle here that they're rotating around. What am I looking for here? This kind of circle that fits within here. So they're all tangential to this kind of arbitrary internal circle. Okay. If I don't choose to rotate them, then they all just sit upright, just like the original was. Okay. Most of the time when you're doing polar arrays, they're usually circles that you're arraying out. So if I make a circle and make a polar array, they're usually circles, so the rotation doesn't really matter that much. The reason they're usually circles is because this kind of exists a lot for things like if you're making a flange. Flanges are usually have circles arrayed out in a polar array because they have stud bolts that go through them. It doesn't really matter which way these are rotated because each of these circles, it doesn't matter if I rotate the circle in any way, it's just going to look the same anyways. So most commonly, you're usually polar arraying circles out. But in the case that you're arraying out some sort of other shape, like the triangles that we showed, you might have to kind of determine whether it's rotated or not. But you can see if I try to rotate these circles, they look the same anyways. Okay. Most oftenly, they're like bolt holes or screw holes set in a circular pattern. So they're not really often some shape otherwise. Okay. Any questions about polar arrays at all?
If you set the distance between the objects instead of just setting the number of objects, would it automatically fill in? Would it automatically generate how the equal number of objects?
Sort of. So if I go back and make my polar array, so I could set the distance between. What's kind of limiting that is my fill in items. I kind of have to change. Let me double check here. Let me think about that. Because I can't change between without changing items. Yeah, so if I change between, the item stays constant, but it changes the amount of fill. Okay, so if
Okay,
right
gotcha.
now, yeah, by default, it's set it to 6 items, so they're all 60 degrees apart. If I change this between down to 25, it's going to change the amount of fill, but keep the number of items constant. Okay. Okay, any other questions at all? I know path and polar work slightly differently, so I always get confused between the two. Okay, there's no questions. We'll move on to path array. Path array is probably going to be the least commonly used of the three. Usually path array is for kind of weird stuff like architectural or landscaping, things like that. It's not, I can't really imagine much of a reason to use it in electrical specifically, but there are niche cases, of course, so it might come up that you might have to use it. So we'll kind of demonstrate it, but it's not going to be highly kind of critical for you guys. But just so you kind of know what it does, and in the rare case that you do need to use it, then at least you know how it works. Okay, so I've kind of made a pre-made drawing here. I have this kind of line here. I have a horizontal line and then a bit of an angle and then another horizontal line. We're gonna make this our little cartoon version of a conveyor belt. That's my green line here. These are my conveyor belts. And this blue box is just some sort of box being shipped or manufactured or something like that. Okay, so my blue box here is traveling up this conveyor belt. Maybe I'm making a little sketch of how that works, how that looks. So path array is going to allow me to create a pattern of objects, again, a specific distance apart maybe. copied along a linear, curved, or irregular path. So it's going to find some sort of polyline path, and it's going to plop those objects down along that path. Okay? So unlike rows and columns or radius, it's going to try to make a bunch of those objects along a polyline and then specify some sort of distance between those objects or a number of objects. Okay? So I'm going to choose path array. That's our second option from our drop menu here. Path array. I'm going to select my box here because I want to kind of demonstrate or make a visual representation that there's many boxes on this conveyor belt. So I'm going to select the box. That's the object that I want to array. Press enter. Next, it's going to ask me to select the path curve. So first, I need to make sure that this set of lines here is a polyline. So I'll join them. And then I'll take this box, use path array. I've selected the box as the object to array. Now I need to select the path curve. I'll use the conveyor belt here as that path. And when I select it, I get a little bit of weirdness here. Make sure this is working properly. It's gone in the wrong direction, hasn't it? Path array, use the square. It really doesn't like going in the right direction. There we go. Slightly better. It's being weird on me. Let's take my box again. There we go. Okay, so it's just arraying in the wrong direction. I've fixed it a bit here. So now it's being arrayed along that path that I've defined. So I had my original box in the left here. Now it's expanding them. It's made multiple copies of that box that kind of go along and then up this ramp and then over to the side. So now I'm kind of demonstrating that there's boxes going up this conveyor belt. Okay. So in path array, we have a few different options here again. First of all, we can define the amount of distance between each box. This is going to change how many items I'm going to have. So it's trying its best to make an array of as many objects as possible that will fit that path. If I change the distance between by increasing the distance between each box, I'm going to get less items. If I decrease the distance, I'm going to get more items. So if I increase this distance to something like maybe 8, now I have the first box. I only have 4 boxes here. First, second, third, and fourth. There's 8 units between each one. If I change it down all the way down to something like 1, then I have a huge amount of boxes here. I have a total of 31, it says. Or 32, sorry. 32 items. Okay. Change the distance between back to 8 here. So I can kind of demonstrate I have these boxes. They're going up the ramp here. Okay. So a few things we have here as well. I can change the distance between, or I can click or kind of check or uncheck the number of items here to actually change the count of items myself. What I also have to do here is change this. Oops, let's leave that. Change this from measure to divide. Measure is going to use the current item spacing when editing the path. So I can change the distance between. If I change this to divide, then I'm changing the number of items and it's automatically choosing the between distance. Okay. So measure, I can change the distance between, something like 8, change the distance between each object, change it to divide. Now I get to choose how many objects are there, and it's going to automatically calculate the between. Okay. So I have this extra setting that's going to switch me between the two different modes there. I can also change the total, and it might expand past where that kind of path goes. And this will all, they're kind of interacting different variables between the number of items, the distance between, and then the total distance of all of the objects. Okay. So set this back to 8. Yeah.
I'm trying to follow along here a little bit kind of while you're explaining this. And I'm trying to do the path array. I've mimicked your line, goes up on an angle in your conveyor belt. But when I do the path array, it seems like my boxes just kind of like go to the end of the first level and then just stop dead. What could be a potential cause there?
It's likely that your 3 lines, are they joined or is it one polyline?
Yeah, I've grouped them.
Okay. Grouped or joined?
Grouped. Join would probably make the difference.
Yes. Grouping is kind of just a user-based thing to kind of lump objects together. Joining actually like more calculatedly fixes them together in AutoCAD's programming. So using join specifically. So right now they're all individual objects. If I use join, I can select and kind of join them together. And now they're just one solid object. Group in this right click here, this right click menu, grouping is just kind of for your own purposes to kind of stick them together. It doesn't actually make that one object. It's just for your convenience to kind of lump them together to maybe move them around. Yeah.
Move them together. Okay. That's good to know. Thank you.
Yeah. Okay. Okay. So I'll change this back to, yeah, no problem. Let's switch this back to between. Change it back so we just have 4 squares here. I've put this distance between as 8 units. We again have an align items button. This is kind of similar to polar arrays rotate. In terms of polar array, rotating made those triangles rotate as they were placed around the polar array. Align items in this case is going to make sure that these objects are placed tangentially to the path that they're attached to. So since this conveyor belt moves at kind of an angle here, there's an angle between these 2 horizontal segments, the squares also rotate to match that angle. If I turn off align items, then they match the original square. Okay, so they're no longer aligned to the path, they're just placed along the path, but with the orientation of the first square. Okay. If I turn on align, then they are both placed along the path and they're aligned to the path that they're actually following. Okay, so the orientation or the rotation changes with the path. Okay, same thing if I make some sort of kind of crazy wavy line here. Oops. Where's my measurements here anyways? 9. Let's do just remove a bunch of this stuff here. Okay, so I have a bit of a wavy line here. If I want to put a bunch of circles along the wavy line, same idea. I can select the object that I want to array and then select the path curve. And I don't think this has been joined properly because of the fillets. There we go. Okay, so now they're all with the path there. I can turn off alignment or on alignment. You can see they're kind of shifting a little bit. That's because they're being placed along the tangent lines. If you imagine a line here being placed tangent to these circles versus when I don't align them, now they're just defined by the distance from the path to the circle. So they all look pretty consistent here. Turning on a line makes them match the tangent kind of shape of this line. Okay. We never have to worry about levels. I forgot to mention with polar as well. Levels is the amount of rows for the z-axis. We're only working in 2D, so we don't have to worry about that at all. We don't have a z-axis, we just have y and x. Okay, so we don't have to worry about the levels at all. That's just for how many layers in the z-axis we have. Okay. Same with this z direction button. That's also just for 3D. We don't have to worry about that at all. Okay. Okay, so I have my boxes on my conveyor. I can just kind of wrap up and bring in some other tools that we've kind of talked about. I can now go back and kind of finish this up. Actually, let's make this a bit more precise. I won't eyeball it. Let's do 0.5. Actually, even simpler yet, let's just copy it. Okay, and then I can use my fillet here. Fillet the two ends. They are polylines, so I'm going to have to explode them again for fillet to work properly. And fillet the ends. And now I kind of have something that resembles a bit more of a conveyor belt here. Okay. I could do the same with these ends if I really wanted to. Do multiple. Okay. And now I have my kind of conveyor belt here with my boxes. Okay. That's pretty much it. With path array, again, I highly doubt you'll really need it that much, but if it does come up, at least you kind of have a bit of awareness of how it works. Okay. Any questions at all about any of the tools for today? Okay. If there's no questions, then the remaining time you can either go through the Chapter 11 practice problems. So Chapter 11, Practice 11C, 11E, 11F, H, and I. Those 5, you can get started on those. On Thursday, we'll go through them together as a class. So we'll go through those 5 practice problems. You can try out extra practice 5, or you can work on assignment 4 or any other assignment. Okay. So the remaining time is just kind of free work period. If you have any questions, or if you want to hang out or anything like that. If you want to leave early, I don't have any problems with that either.
Question for you.
Yep.
I'm doing the assignment 4. I'm doing the dressing rooms. Is there supposed to be like a way to do evenly spaced throughout everything?
Evenly spaced for the luminaires, you mean? The light symbols?
Like I'm doing the
Or
grid.
the grid. Yeah.
Yeah, I'm doing the grid. And my the way I'm doing it just isn't lining up correctly.
Is it
It's
just a
like,
little bit off? Is that why?
yeah,
Okay, so the as long as you're following the Luminaire or the Luxaflux zonal or the details PDF, as long as you're following one of those, you should be fine. The drawing itself is a little bit inaccurate. So
okay. So like I went like 1700 in on either side, and then I went 2169 between each one, and then it gets off by 1 point on the last one. And I did
yeah,
the next dressing room over. I went 1740 in on either side, and then 2271 across, and I'm like 3 or 4 out.
yeah. The drawing itself isn't perfect, is exactly why. If I go here and just remove the grid I have here already and just measure the room itself, you can see that it's not really perfectly accurate. It's like
Okay.
6.6 and some change for the meters of this room, 14.8 and some change. It's not going to match perfectly with the Luxaflux, where it
Okay, so
says
don't worry
that this
about being
should
too
be.
exact kind of thing. Okay.
Yeah. The limitation is that the Luxaflux itself doesn't go to enough decimal places. So since your information is skewed in that way, I'm not going to penalize you for being out a little bit.
Okay.
That being said, you should follow these specs to the best you can. If it's completely out, then there is a problem. But if it's within a reasonable tolerance, like 50 centimeters or so, then you're fine.
Okay.
Yeah.
Hey Brent, what when they have on the schedule,
Yep.
all the writing and stuff, and those blocks that indicate the different types of numbers with the 100, 200 in the center of them.
Yes. Yep.
So planting those in the different rooms to indicate which lights are being used. It didn't really say in the instructions document, like in the PDFs,
Yep.
if you wanted to keep them on the same layer as the schedule or change those blocks to the luminaires layer.
Yeah. Good point. So, what the sample has and what I think should generally be done as well is that the symbols should be on the luminaire's layer, just
Okay.
because it's associated with those symbols on the
Okay.
drawing itself. That being said, if you do end up using the schedule once, I'm not going to penalize you because it's not explicitly said in the instructions. So I best practice would be to match it to what the symbols it's trying to represent are. But yeah.
Okay, that makes sense.
Yep.
I'm gonna duck out. Thank you, Brent. Have a good night.
Yep, no problem. See you next time.
Sounds good.
Hey, Brent.
Yep.
So I'm looking at dressing room 2 and 1 here, and I'm trying to do the grid layout for them, for the lighting layout. There's no marker on it for space off the wall for what it's looking
Two
for.
and two and one.
Like there's no indication for space off the wall. Like
Are
off
you
the
looking
edge
at
of the wall.
the details PDF?
Yes.
Okay. So
Arena AutoCAD lighting layout details.
okay. So something to keep in mind here. If you use the details dimensions, dressing room 4 and 2 have the same dimensions. So if I go back to my Luxaflux here, 4 and 2 are lumped together. They have the same room dimensions, same lighting layout. So I
Okay.
might have to pull information from where is it here?
So just copy and
Dressing
paste it
room
over.
4. Yeah. So the offsets for dressing room 4, you can copy them to 2. Same with 3 and 1. 3 and 1 are the same dimensions as well.
Okay. Awesome. Thank you.
Yeah. Yep, no problem, Abdul. See you next time. Yep, no problem, Roberto. See you then. Yep, no problem, Mike. See you next time. Any final questions before we shut down for today here? Okay. If there's no questions, by all means, you can always email me as well if you have any specific questions or anything. Just be kind of particular with what your problem might be, and then they'll help me kind of figure out what might be going on, and then we can go from there. Okay. So email's always open. I'll try to get back as soon as possible. Otherwise, I'll see you guys Thursday.